Okay, I think we can start our class. So what were we saying? We started with friction. Okay, the friction number is contact force. Okay, we have also seen Coulomb's law of friction. Coulomb's law of friction is F is equal to force mu times n Coulomb's law. So this I have told you in class before. So maximum friction force is mu times n. Okay, so this is Coulomb's law. So now last so we have seen a block we are trying to slide. Okay, so in the rough surface contact. So when the surfaces are rough, the friction will be there. Okay, so etra force on apply in the force of friction will self-adjust up to some certain level. We force apply it will not move. This force to move apply opposite force friction apply. Okay, so if you keep on increasing the force, what will happen is the friction also will keep on increasing up to certain point. So that is why this is a force which I am applying. This is a friction force. So I friction force friction force friction force force friction force force friction force friction force. So this will go up to certain limit. So this the friction force in the value force in the value both are same, mu times n. Mu times n. Even okay, it is lesser than mu times n. Okay, okay, it is lesser than mu times. So now to apply in the force, maximum friction force in a cutting the friction force will be equal to the applied force. Okay, once it reaches this value, it will be the maximum value. The body starts to slide. Slide friction value it will come down. Because we have two friction coefficients. One is static friction coefficient, second is dynamic friction coefficient. Okay, more we put dynamic friction coefficient, it is a lesser value than static friction coefficient. So we just have to deal with static friction coefficient. Okay, so two things that you have to remember is friction is a self-adjusting force. The maximum value of friction is mu times. So maximum value of friction is mu times. Okay, so it doesn't mean that maximum value is. So that also we will see with an illustration. So we talked about dynamic and static friction. Then we saw the direction of the friction. Friction direction. It will always oppose the direction of the motion. But this is trying to move in this direction, so the opposition will be in the friction will be in this direction. Okay. Now this block we are attaching to with the string. The other block we are trying to slide, but there will be friction here. So in the smooth item, friction. So this body is trying to move in this direction, so there will be friction in this direction. Okay, so this body is trying to move in this direction with respect to this. This body is applying friction on this. So we will assume that you are sitting on this body. You will see that this body is going in this direction. You have to apply a friction force in this direction. Now about this body, you have to assume that you are sitting on this body. We are feeling that this is going back. Okay, so this is going back, so we have to apply a force in the other direction. So that is why friction force body in direction. This is box in the free body diagram. Box in the free body diagram. Okay, this is friction force this is friction force value same because the contact force is same. Mu times the contact force is the friction. Contact force equal and opposite. That's friction of equal and opposite. Right. So I hope that is clear. Again, we have seen friction direction. Then we talked about angle of friction. Now, in the question, mu what is angle of friction? You just have to do tan inverse to get the angle of friction. Angle of friction is normal force resultant of normal force and friction angle of friction. Okay, so that is equal to tan inverse of mu. Okay. Then we also talked about problem solving. Then we were talking about angle of repose. So angle of repose in the literal meaning is sleep, is basically the angle at which a body start to slide with its own weight. So the weight slide on a rough surface. Okay, so we'll take our class from this point. Restart. Okay, so angle of repose, how do you find angle of repose? Angle of repose കണ്ടുപിടിക്കുന്ന എളുപ്പമാണ്. You just have to remember the condition, criteria. Angle of repose in the criteria. അതായത് okay, so that is basically I'll call some angle, let's say alpha, at which the body starts to slide down and rough inclined surface. Okay, so what is the condition? So let's say we have this inclined plane. Let's say the angle is alpha. Okay, let's say we have a box over this plane. Right? We have to find that angle. നമ്മൾ ഇത് ആംഗിൾ കുറച്ചിരിക്കുമ്പോൾ horizontal plane ഒരു ബോക്സിനെ നമ്മൾ റെസ്റ്റ് ചെയ്ത് കഴിഞ്ഞാൽ it will just stay there. You just keep on increasing the angle. You can observe that at some angle it will start to slide. Angle and angle of repose. Okay, so let's say we are at that angle. The angle it will just start to move. അതായത് all the forces should be in equilibrium. Move ചെയ്യുന്നില്ല, പക്ഷെ just about to move. തുടങ്ങുന്നതെന്ന് എപ്പോഴാണ് when the force which is pulling it down is equal to the friction force. Friction force ന്റെ maximum value equal ആവുമ്പോഴാണ് അതിനെക്കാട്ടി കുറച്ച് കൂട്ടി കഴിയുമ്പോൾ നമ്മൾ ഫെയിൽ ആവും. സോ താഴോട്ട് സ്ലൈഡ് ആവും. അപ്പോൾ ആ ഒരു മൂവ്മെന്റ് ആണ് നമ്മൾ അനലൈസ് ചെയ്യാൻ പോകുന്നത്. So as usual, let's say the coefficient of friction is mu. That's the weight VW. Okay. Now we have to first draw the free body diagram. In the free body diagram, free body diagram, we have to identify what are the forces. So we have to isolate this body. The body isolate here to draw the free body diagram. Okay. So one force I know, and another W. Then I know a normal force. A normal force in this direction. So this I will shift to a normal force. Just for representative convenience, using transmissibility, I can shift it here. Okay, so I'll call this normal force or contact force as N. Then what is the other force? One force is the friction force. Okay, friction force is always perpendicular to the contact force, and it is on the surface. So my friction force will be in this direction. Friction force. Okay, this is equal to mu times N. The mu times N now up to maximum value of friction force is mu times N. Okay, mu times N ആവുന്ന ഒരു കണ്ടീഷനാണ് നമ്മൾ എടുക്കുന്നത്. Because അതിലും കൂടുതൽ ഫ്രിക്ഷന്റെ maximum value ആണ് mu times. So we are taking that condition. Now what we have to see is this is the time in which this is the point in which it will start to ഈ ഒരു arrangementലാണ് അല്ലെങ്കിൽ ഈ ഒരു force act ചെയ്യുന്ന സമയത്താണ് it will just start to slide. Okay, now how do you find that? So it is always better to find an axis which is along the motion. ഒരു മോഷൻ along the motion ഉള്ള ഒരു ആക്സിസിൽ നമ്മൾ റെപ്രസെന്റ് ചെയ്യുന്നതാണ് നമുക്ക് ഏറ്റവും എളുപ്പം എപ്പോഴും. So I'll just draw that axis here. So this is my local x-axis. This is my local y-axis. Okay. So this, how do you find this angle? So we'll go back to our original figure to that angle. So some of you may be knowing this angle also. Okay, so this is it. How do you find that? So to find an angle, what I'll do is I'll first try some basic geometry. I'll apply. So let's say I am drawing a rare axis. Okay, so this axis is nothing but an original figure in the 2D plane axis. This is axis. So what you can observe is here is this line and this line are parallel. Okay, so that means this angle is also alpha. This time is also angle. So this is two parallel lines. This parallel. So this alpha and this alpha. This alpha. Okay. Now I'll extend this also. Axis. So this angle is alpha, means this angle is alpha. If you have two parallel lines, we have a line here. These two are opposite interior angles will be same. Okay, so similar way, there is a horizontal line here, there is a horizontal line here, there is an inclined line. Okay, so if this is alpha, this is also alpha. At alpha angle, you can see this is 90 degree, this is 90 degree, so this is 90 minus alpha. Okay, and you can also observe this is 90, so this will be back to alpha. Is alpha. I hope this is clear. This 90 degree, this alpha, so it will be 90 degree, 90 minus alpha. 90 minus alpha into some value equal to 90 degree. So that value should be plus alpha. 90 minus alpha plus alpha be equal to 90. Okay. So if this is 90, these two angles are, if you see these two lines, E line and E line, opposite angles are. So this also alpha. That means this angle is alpha. Okay. Now this is the angle that we needed. Either 3 alpha angle. Now what we'll see is E or plane X in E or plane Y denote or X dash Y dash denote. Now we are observing the equilibrium of this body in this E axis, E X dash and E Y dash number present here. Okay, because it is easier, right? So it is an equilibrium means all the forces in X dash should be equal to 0. All the forces in Y dash should be equal to 0. Okay, so we'll trust it ourselves to translation. Moment because rotation constraint. Now, what is the forces in X direction? So this is X direction. So I can say X direction or B than X direction. This is positive. Y direction or B than Y direction. Angle and Y direction. This is positive. Okay, so this is positive. This is positive Y. So X direction. What are the forces? So if I observe this, X direction force. There is a friction force that is mu times N. So that is positive because it is towards the right. Okay. Then we have a force. Then the component of the force we can split into two components. So this is W. So this will be W sine alpha. This will be W cos alpha. Components. This is W cos alpha. This is W sine alpha. So this is minus W sine alpha equal to 0. Karanam the direction negative. Okay. So this is one equation that I will use. Second equation is summation of all the forces in Y direction equal to 0. Inclined plane up is positive. So we have a normal force here, which is plus, and we have a W cos alpha, which is downwards negative. Okay. So that means N equal to W cos alpha. So this is 2. So and this is mu N equal to W sine alpha. This is 1. Okay. So if I do 1 divided by 2, the 1 divided by 2 is mu N upon N equal to W sine alpha upon W cos alpha equal to tan alpha. So this will get cancelled out. So tan alpha is equal to mu. Okay. So that means alpha equal to tan inverse of mu. So this is nothing but the angle of friction. Okay, so we can conclude that angle of friction and angle of repose are one and the same thing. Angle of friction is the angle of friction importance. You have a surface and the surface and angle of friction. Friction coefficient angle of friction. Angle of friction angle a plane on that plane body self weight slide. Okay, body angle and slide answer. Coefficient of friction coefficient of friction angle of friction. Angle of friction is angle of repose. Okay, so both represent the same thing but gives a different meaning. Angle of friction is tan inverse of mu1. Okay, angle of repose is that angle at which a body which starts sliding with its own weight. Okay, so I hope this concept is clear. Confused. Angle of friction and angle of repose it is angle of the plane at which it starts to fall. So this is an important concept. Angle of friction on the term is important. Angle of repose is an important concept. Just remember this. Try to remember this concept. Okay, now what we will do is we will start solving some problems. Okay, friction question problems solve. So what I will do is I will illustrate two problems maybe in class. Simple problems in class will illustrate. I will give you some recorded videos of more problems. Okay, so what I will do, I will try to record some videos today. And the question problems in the record. This will not get over. Class will do. So I recorded videos in the session. I will give you some assignments. So try to solve the assignment. So assignment in the mark column, I will start displaying marks also now based on your submissions. I need a volunteer. I need somebody's help in organizing my assignments. So you can WhatsApp me. There is some work. I'll volunteer. I'll be happy because I need help. Okay, so somebody is there. Just WhatsApp me after the class. Right. So first question. So let's try to answer one question. So let's say this is a box. Okay. P. There is a force P here. It is at 55 degrees. Coefficient of friction 0.25. Okay. Find the magnitude of P for which the box just starts to slide. Okay, so slide here. Slide. The weight of the box is weight of the box is what is it? 300 newtons. Okay, so there is a force P here. So it is acted at an angle 45 degree. 45 degree angle on a force acted. Okay, so this is a rough surface. That is why coefficient of friction is there. It's a rough surface. It's a rough surface. So what is the value of P for which the box just starts to slide? Slide value. Okay, so the first thing is you have to draw the free body diagram. The free body diagram. The free body diagram it is easier because most of the things are given here. We'll just copy this. I'll complete the box. I am freeing the box. Forcing I am free at. Okay. So what are forces we have? We have a normal force here, or reaction force here. You can call it R, or I'll call this N. Okay. We'll also have a friction force. But this has a tendency to slide in this direction. So that means the friction force will be in opposite direction. Okay, friction force. Okay. So when it just starts to slide, okay, so when the body just starts to slide, the friction force will be equal to mu times n. Friction force slide ചെയ്യാൻ സമയത്ത് അതിന്റെ value mu times n. Okay, so that is the condition that we are going to use. Mu times n is the normal contact force here. അപ്പോൾ അതങ്ങനെയാണ് friction force define ചെയ്തത്. Okay, so now we have to just apply equilibrium. Equilibrium നമുക്ക് apply ചെയ്ത് കഴിഞ്ഞാൽ we can solve this. Okay, so this means, so let's say just move it or move it. So that is why we are telling summation of forces in x direction should be equal to 0. So this is my x, this is my y. Okay, summation of forces in y direction should be equal to 0. Okay, so let's say x direction this is positive, y direction this is positive. So we will work with x direction. Up x direction number. It will be better if I just replace this with component. Okay. This force has two components. So one component is this, that is P cos 45. There is P sin 45. Component you should know by now. Okay, so this is the full free body diagram. I will use this for the use. So let's say x direction will be the direction, right is positive. So that means we have a P cos 45 here with a plus sign. We have a minus mu n there. Then this should be equal to 0 because it is not accelerating, it just started to move. So that means acceleration is 0. It is just on that moment. Okay, so P cos 45 is equal to mu n. So this is one equation. Second equation, we will take this. Okay, so upward is positive. Upward positive is P sin 45 is there. It is positive. We also have plus normal force. That is also upward direction. This is equal to 0. Okay, so what we are observing here is number normal force is normal force of friction force in random or a direction active. Okay, this is the moment. Okay, so I think we missed one force. Weight is 300. Okay, so that is why I was also looking into the missile. Okay, so we have P sin 45 upward, we have a normal force upward, we have a minus 300 weight. Equal to 0. Okay, so from this we can write n equal to 300 minus P sin 45. So this is my 2. So I'll substitute this value of n in this, and that will give me what will it give? So let me see. P cos, so cos 45 is 1 by root 2. Okay, so that is P by root 2. So I'll elaborate. P cos 45 minus mu into 300 minus P sin 45 should be equal to 0. Okay, now we will substitute the values. P by root 2 minus, what is the value of mu? 0.25 into 300 minus P by root 2 equal to 0. Okay, so now we have to solve this. So we will solve this. Simple maths, hope it is clear to you. So P by root 2 minus, so 75. So 325 into minus 75 plus 0.25 p by root 2 equal to 0. So minus 0.25 into minus p by root 2 is plus 0.25 p by root 2. Okay. So this is p by root 2 into 1 minus 0. So 1 plus p by root 2 plus 0.25 p by root 2 equal to 75. Okay. P by root 2 into 1 plus 0.25 equal to 75. P by root 2 into 1.25 equal to 75. P equal to 75 times root 2 upon 1.25. So what is the value? 75 times root 2 root 2 upon 1.25. 84.84. So this is the value of P. Okay. So I hope this question is clear. Important thing is you have to understand the concept. In the concepts, you have to ask. So weight marker, weight you have to put. So it is very natural. We'll miss all those things. So P cos 45, P sin 45 on a component, component mu n. So one important concept is for which the box starts to slide. Slide just maximum value of friction slide. F equal to mu n. The maximum value friction force will be lesser than mu n. Okay, mu n or maximum value of friction force. So I hope this is clear to you. So we'll take another problem. Let's take a new problem. Slightly complicated area. Okay. So let's say we will tie this up. There is a box. Okay. Then we have, let's say, another box here. Okay. It is resting on a surface. Okay. So there is contact here. Contact on contact. So let's say there is contact here. Mu equal to 0.3. There is also contact here. Okay, so this contact is there. We are applying a force here. We are applying a force here. Okay. This is having weight of 500 newtons. This is having weight of 300 newtons. Okay. So what you have to find is find the value of F required to just move the bottom box. Also find the force in string. Okay, so this is a string. This is a string. Okay. So it attaches again. This is attached fixed. 500 Newton force under box under where box ഇതിന്റെ free body diagram. First step is always to draw the free body diagram. Okay. The free body diagram we'll isolate the bodies. So let's say I have this body here. This body also. Right. So this 300 is acting downward. Okay. So there's a force here, F, acting down rightward. We have a reaction from this bottom. Okay. So we have a reaction here. So that I'll draw here. Or maybe I'll draw here. So just give me a moment. This is the weight, which is equal to 300 Newton. We have a reaction here, N1. So N1 is here from the because of this surface. Okay. We also will have a friction force in this direction here. F1. We'll have a friction force in this direction. Even under contact, so there will be a contact force there. Okay, so this body will be applying a force on this body. This body will be acting a force on this body. It will be downward. So that also remember that. The first class will be contact force. This is N2. Okay. Now there will be a friction force because of this contact. Under contact number of friction force. It will be mu times this N2. What will be the direction? Direction is simple. You stand on this box. You see how this box is moving related to this box. So ഇവിടെ നിൽക്കുക കഴിഞ്ഞാൽ ഈ ബോക്സ് ഇങ്ങോട്ടാണ് മൂവ് ചെയ്യുന്നത്. അപ്പോൾ ഫ്രിക്ഷൻ ഫോഴ്സ് ഷുഡ് ബി ഇൻ ദിസ് ഡയറക്ഷൻ. സോ ദിസ് വുഡ് ബി F2. Okay, force of this friction will be F2. Is there any other force? നമ്മൾ weight measure ചെയ്തു. ഇല്ല, I think everything we have measured. Now we will take the second രണ്ടാമത്തെ. So I'll just get rid of this string. Now, one thing that you have to observe is this body will be at rest. ഇതിന്റെ ഈ ബോഡി ഇതിന്റെ അടിയിൽ നിന്ന് പോയി കഴിയുമ്പോൾ താഴ്ത്ത് വീഴത്തുള്ളൂ. അല്ലെങ്കിൽ till then this body will be at rest. This body will be starting moving. അത് രണ്ടുമാണ് നമ്മൾ പറയുന്ന കോൺസെപ്റ്റുകൾ. Okay. Now, let us see how do you calculate that. Okay. Two things you should remember. One, ഈ രണ്ട് കോണ്ടാക്റ്റിലെ ഫ്രിക്ഷൻ ഫോഴ്സും overcome ചെയ്താലേ ഈ ബോഡി മൂവ് ചെയ്യുള്ളൂ. Okay, so that means the friction force of this should be maximum, friction force of this also should be maximum. That is one thing. Okay, and this body should be at rest. That's the two things that you should consider. Now, I will have my weight here. It's 500 Newton. So, നിങ്ങൾ കേൾക്കുന്നുണ്ടല്ലോ അല്ലേ? This is 500 Newton.
Yes, sir.
Yeah, fine. So this body will be acting a contact force on this body. So that will be my head. Okay. Then what we have? What is the other force? Now, if there is a force in this string, so that I'll call as tension or some strain, some force. So let's say I'll call this force as T. Okay. Then there is two surface here. The friction, each surface, the friction, there will be a friction due to this body on this body. Okay, what is the direction of the friction? So, you can observe that when you stand in this body, this is going backward. Okay, with the friction force has to oppose that. So, the relative motion in the so this will be in this direction. The value of this will be same as F2. With same and equal and opposite. Okay. So if I place it in order, it may be more clear. Okay, so ഈ രണ്ട് കോണ്ടാക്റ്റും ഈക്വൽ ആൻഡ് ഓപ്പോസിറ്റ് ആയിട്ട് വരുന്നു, ഈ ഫോഴ്സും ഈക്വൽ ആൻഡ് ഓപ്പോസിറ്റ് ആയിട്ട് വരുന്നു. ഇവിടെ ഒരു ഫോഴ്സ് ഉണ്ട്, ഇവിടെ ഒരു ഉണ്ട്. Right? So you have to observe both boxes should be in equilibrium. One, this box will not move because it is held by string. This string is stop here. This box will move. Okay, so if this box has to move, both of these friction forces has to be overcome. അതിനർത്ഥം ഇത് രണ്ടും മാക്സിമം വാല്യൂ വന്നു കഴിഞ്ഞ് അതിനെക്കാട്ടും കൂടുതൽ ഫോഴ്സ് വന്നാലേ ഇത് മൂവ് ചെയ്യുള്ളൂ. So till that time both are static friction because it is not moving. Okay, so my F1, the value of F1 I can simply state, I can apply that equal to mu times N1. Value of F2 will be mu times N2 because it is mu times the contact force. Here the contact force N2 ആണ്, normal force, here the normal force N1 ആണ്. Okay, mu times N2, mu times N1. So this is F2, it is also equal to mu times N2. So force will getting, so I will take box 1. So I have to name these boxes. I'll call this as one first box, this is second box. So we'll work with box 1 now. Box 1. Okay, summation of all the forces in x direction should be equal to 0. So this is x, this is y. Right, positive. So box 1 is x direction and positive force. It is simple. We have a t here. T is in this direction, so that will be minus. Okay, we have a F2 here, plus F2 the value is mu N2. Mu N2 equal to 0. Okay, now we will see summation of forces in y direction equal to 0, up positive. Okay, so what is upward force? N2, that is a plus minus 500 equal to 0. So that means N2 equal to 500 Newton. So this is a result that we can use. Okay. So directly if I substitute it here, I'll get the value of T. So T equal to mu times N2. This is equal to, what is the value of mu? Mu is 0.3. ഇതാണ് mu. ഇവിടുത്തെ mu ആണ് നമ്മൾ നോക്കേണ്ടത്. It is 0.3. ഇത് രണ്ട് വാല്യൂ ആകാം കേട്ടോ. 0.3 0.3 times what is N2? 500. So this is equal to, so T equal to 0.3 times 500, 150. Sorry, 150. Okay, so that is a force the string is putting on the body. So that is box 1. Now we will talk about box 2. Box 2. Same equations we can apply because it is in equilibrium. Force x equal to 0, right, positive. Okay. X direction and the can force. We have an F which is unknown, which is also positive because in the right direction. We have a mu times N1, that is a minus sign. Mu N1. We have a mu N2, that is also minus sign. Okay, so N1 the value namakariam, sorry, N2 the value namakariam, mu times N2 the value namakariam, it is 150. Okay, so we can say F minus mu N1 equal to mu times N2, that is 150. Okay, so this is an equation that we'll use. We will try to find the other equation also here. Summation of all the forces in y direction should be equal to 0, up positive. Okay, this is box 2 ആണ് നമ്മൾ നോക്കുന്നത്. This is 2, this is 1. So box 2 up y direction എന്തൊക്കെയാണ് ഫോഴ്സ് ഉള്ളത്? So there is an N2 which is downward, so minus N2. There is a 300 which is downward, so that is minus 300. There is a N1 which is upward, plus N1 equal to 0. Is there any other force? Any other forces missed out? No. Now N1 we know N2. N2 ന്റെ വാല്യൂ നമുക്കറിയാം, minus 500 ആണ്. So minus 500 minus 300 equal to N1. So that means, so it's a plus N1 equal to 0. So N1 equal to 800 Newton. Okay, so it makes sense. കാരണം ഇതിന്റെ റിയാക്ഷൻ എന്ന് പറയുമ്പോൾ 500 plus 300 800 ആയിരിക്കും ഇതിന്റെ റിയാക്ഷൻ. നമുക്ക് ഊഹിക്കാവുന്ന കേസുള്ളൂ, പക്ഷേ we are getting by equation. Okay, so observe this. N1 is the body in the manner to force. This floor is putting a force on these two bodies. Like this body to force apply. That's these two bodies weight equal. So but then we have to solve this by maths. So this is 800. We'll substitute it here. Okay. So what will you get? F minus what is mu? 0.3 times 800 equal to 150. So this gives me F equal to, so 150 plus 0.3 times 800. 390. 390. 390 Newton apply cheyidina, what will happen? This will start to move and the force in the string will be equal to 150. This force apply in the string T. So that will be the force in the string. Okay. Right. No, tension in the string and the concept of we can just give me a moment. So this is the force in the T is the force which is applied by this string on the box. Okay. So what is the force that is the that is a force that is this box applying on the string? Equal and opposite. So that is also there. We will look into that later. Okay. Or rather, yeah. So that is it. We can again complicate these things. Complicate. So for example, let us take the same problem. Take it here. Okay, good. So this is the problem. Just rotate it. Let us say this angle is P. Okay. Now we can just ignore this force. Okay, we can say find the angle P such that block 1 starts to slide. Okay, എത്ര ആംഗിളിലാണ് ഇത് സെറ്റ്? അപ്പോൾ ഇത് നിങ്ങൾക്ക് രണ്ട് ബ്ലോക്ക് ഉണ്ട്, അതുകൊണ്ട് just blindly go the tan of ഇതിന്റെ ആംഗിൾ ഓഫ് ഫ്രിക്ഷൻ കണ്ടുപിടിച്ച് അതായിരിക്കും ഇത് നിങ്ങൾ ബ്ലൈൻഡ് ആയിട്ട് ചെയ്യരുത്. ഒരു സിംഗിൾ ബ്ലോക്ക് ആണ് തന്നിരുന്നെങ്കിൽ ഒറ്റ ഫ്രിക്ഷൻ കോഎഫിഷ്യന്റ് ഉള്ളെങ്കിൽ we can say that is the same force. Now it is different. ഇത് മൊത്തത്തിൽ കേസ് മാറിയിരിക്കുകയാണ്. ഓക്കെ, അപ്പോൾ ഇത് ചോദിച്ചിരിക്കുന്നത് what is the force, what is the angle at which this will start to slide? Okay, എന്തുകൊണ്ടാണ് സ്ലൈഡ് ചെയ്യുന്നത്? ബിക്കോസ് വെയിറ്റ് ഉണ്ട്, ഇതിന്റെ വെയിറ്റ് ഇതിനെ ആക്ട് ചെയ്യും, ഡയറക്ഷൻ ആക്ട് ചെയ്യും. ആ വെയിറ്റ് ഇതിന്റെ വെയിറ്റും ഇങ്ങനെയാണ് ആക്ട് ചെയ്യുന്നത്. വെർട്ടിക്കൽ ആയിട്ട് ആക്ട് ചെയ്യും. It will have a component in this direction. Okay, so those weights are what is driving it. അതിന്റെ weights ആണ് ഡ്രൈവ് ചെയ്യുന്നത്. Okay, so what we will do is I don't think we can complete this problem. Before that, നമ്മൾ free body diagram വരച്ചിട്ട് ശേഷം we can stop it. Okay, so what we'll do, we'll draw the free body diagram. So let's take this. This is one body. This is another pole. Okay. So let's mark all the forces that we can find. So there is a contact force here. So there will be force in this direction. Contact force on top. So the value of contact force is N1. Okay. Yeah, N1. Then there will be a gravity force here, vertically downward, acting vertically downward. That will be the weight of the body. So which is equal to 300 Newton. Okay. There is a friction force here. I'll call this F1. There is a contact force between these two, which will be in this direction, N2, and there will be a friction force in this direction, same as similar pole. Okay. So this friction is because of this. This contact. Friction. So this is called as F2. Okay. Well, the question is, what is the direction of the friction? So what you have to see with respect to this box, how is it moving? If done to box, we have to see what is the relative direction. Okay, direction of the force. Direction so if you observe it, we can see that this body is moving in this direction with respect to this body. Okay, so in opposite direction of friction. Okay, but ഇവിടെ ഒരു ഫ്രിക്ഷൻ വരച്ച് കഴിഞ്ഞാൽ ഇതിന് ഓപ്പോസിറ്റ് ഡയറക്ഷനിൽ ഇവിടെ നമുക്ക് അതേ ഫ്രിക്ഷൻ ഫോഴ്സ് വരും. ഇവിടെ നമുക്ക് അതേ കോണ്ടാക്ട് ഫോഴ്സും വേണം. Okay, then we also should have a weight acting downward. This is 500. Okay, and we also have a force due to string. A string in the force moment, that is this. Okay, so this free body diagram varakkilana most challenging job. Idu varakkiyanengil you are set. Idu very clear aayittu ningal free body diagram varakkunnu 90% of your work is done. Okay, so I hope this is clear. If you have any doubts, please be free to ask. Unmute your ചോദിക്കാം. Okay, any stupid doubts is okay, because it is very important that you ask doubts. Okay, now one thing, നമ്മൾ നേരത്തെ കണ്ട ഒരു fact നിങ്ങൾ ഇവിടെ യൂസ് ചെയ്യണം. That is നിങ്ങളുടെ ഈ angle, ഈ angle, this will be alpha. Alpha or P, sorry, this will be P. This will also be P. Okay, now we have found the angle. അപ്പോൾ ഇനി നമുക്ക് box 1, box 2. Okay, always we will try to inclined problem, always try to use this axis, E axis and use, yes, it will be easier in that sense. Okay, if I use block 1, so this is my positive axis, this is my positive axis, this is X, this is Y. Okay, so summation of all forces in X direction, capital X direction should be 0. So provided that this is my positive X. ഈ ഡയറക്ഷനുള്ള എല്ലാ ഫോഴ്സുകളും ഞാൻ എന്താ പറയുക പോസിറ്റീവ് ആസിഡ് ചെയ്യാം. സോ വാട്ട് ഇറ്റ് ബി ഈസിയർ ഈസ്, ഞാൻ ഇത് രണ്ടിന്റെ just make a copy of these two. Okay, and ഈ രണ്ട് ഫോഴ്സും I will replace by components. So this will be P, this is P, angle is this, is an angle, angle we can observe, always remember we have to check angle. So this normal idum thammilulla angle aanu same as alpha. Okay, so നമ്മൾ derive ചെയ്തിട്ടുണ്ട്, നിങ്ങൾ ഇതിന്റെ റെക്കോർഡിംഗ് കണ്ടാൽ കൺഫ്യൂഷൻ ഉണ്ടെങ്കിൽ ഇപ്പൊ ഇതിന്റെ നോർമലും ഈ ആംഗിളും P ആണ്. So this is P sin alpha or sin P. So 500 sin P, I'm sorry. 500 sin P and 500 cos P here. 500 cos P and 500 sin P and E direction. Okay. Again, this also we can replace by forces. So this is one force is in this direction. Other will be in this direction. This will be equal to 300 sin P. P is the angle. Okay. This will be equal to 300 cos P. Okay. So we have forces. Direction, all direction force കിട്ടി നമുക്ക് ഇതിന്റെ components എടുത്തു കഴിഞ്ഞാൽ നമുക്ക് solve ചെയ്യാം. So now it should be easier. Right. Block 1. All the forces in capital X direction should be equal to 0. This direction is positive. Okay. So in the directional force, so this is 500 sin P. This is positive. We have F2, which is also positive. We have T. This should be equal to 0. Okay. We also can write summation of all forces in capital Y equal to 0. This is positive direction, so this is positive. N2 is there, which is a positive sign. 500 minus 500 cos P. This will be equal to 0. Okay, vertical direction, E direction force N2 upward, 500 cos P downward. Okay, so this is another equation. Now we can always substitute. What is the value of F2? So this is F2, sorry, sin 2. So this is positive, this is positive, this is negative. This is negative. Okay. Okay, what is the value of F2? F2 in the value in the mu times N2. F1 the value in the mu times, so this is F1, mu times N1. E normal force, the normal force ആണ് mu N1. ഇവിടെ E normal force into mu ചെയ്തു കഴിഞ്ഞാൽ നമുക്ക് friction value കിട്ടും. Okay. Right. Now block 2. Block 2. Block 2 ൽ എന്തൊക്കെയാ ഫോഴ്സുകൾ? Summation of all forces in capital X direction should be equal to 0. So capital X എന്ന് പറയുമ്പോൾ E direction ആണ്. So 300 sin P, this is a positive, minus mu times N1 minus mu times N2 equal to 0. Summation of forces in Y direction should be equal to 0. Y direction idana. So this is positive. Ingotu positive ആണ്. So that is we have minus 300 cos P plus N1 plus N2 should be equal to 0. Okay. So we have 4 equations. 1, 2, 3, 4. ഈ 4 ഇക്വേഷൻ ഉപയോഗിച്ചിട്ട് നമുക്ക് P ന്റെ വാല്യൂ N1 ന്റെ വാല്യൂ എല്ലാം നമുക്ക് കണ്ടുപിടിക്കണം. Okay.
Sir, minus N2.
Minus N2. Sorry. Minus N2. Okay. So N1, N2, P and mu. P നമുക്ക് ഈ ഇക്വേഷൻസ് ഉപയോഗിച്ചിട്ട് നമുക്ക് കണ്ടുപിടിക്കാം. Okay. So we will solve this equation. നമുക്ക് അടുത്ത ക്ലാസ്സിൽ നമുക്ക് ഇക്വേഷൻ സോൾവ് ചെയ്യാൻ പറ്റും നോക്കാം. We will see how to solve this. Okay. So T കണ്ടുപിടിക്കണം, P കണ്ടുപിടിക്കണം, N1 കണ്ടുപിടിക്കണം, N2 കണ്ടുപിടിക്കണം. ഈ 4 വാല്യൂ നമ്മൾ കണ്ടുപിടിക്കണം 4 ഇക്വേഷൻ ഉപയോഗിച്ചിട്ട്. I think we can solve this. നിങ്ങൾക്ക് കണ്ടുപിടിക്കാൻ പറ്റും എനിക്ക് തോന്നുന്നു. Okay. നിങ്ങൾ ട്രൈ ചെയ്യൂ. You can also try. നിങ്ങൾ ഇക്വേഷൻ 4 ഇക്വേഷൻ സോൾവ് ചെയ്യാൻ നിങ്ങൾക്ക് അറിയാം ഇപ്പോൾ. So try to solve and find the value of P. Maybe you can tell me in the next class. I will also solve. Okay. So I think we will end our class today.